Hey, welcome to my final project. It's called Ross Kelly BATS, Banking and Transaction System. Just as a high-level overview, this is a banking system that tracks transactions and um, different card accounts, checking, savings, credit cards, different users and businesses logged in and tracking their accounts, and then activities on those. Um, some highlights of this system is that it is a full system to be able to have different branches and whatnot. Um, Different users can hop in and have multiple accounts. They can share accounts with others. They'll have different permissions on those. And it is able to generate credit cards and track all of that progress. This becomes really handy because we can integrate with farms kind of two different ways on how we track those credit cards as well as different transactions. So to start, I'd like to show just the first interaction. We have a query to farms to get some information. Basically, what this might represent is if we were adding a transaction into the banking system, we might want a specific description from farms on maybe the hotel name, where this hotel is located, extra comments, and the category. So this is exactly what we'll extract. And if we take a look at the result, we do get some of that information. Um, and then we could take this information and concatenate it together, modify it, and then insert it as a transaction record or a comment into our transaction history. Another portion that ties directly to farms is the ability to validate credit cards that are in our banking system. Basically, let's say someone swipes their card, we can reach out to this BATS and verify that that credit card is actually in their system and it's valid. Um, so let's take a look at some of these credit cards. So here's the first one. This is a valid credit card. Um, Basically, it consists of 16 characters, card type, the account type, and a check digit. We'll go over that shortly. But just to demonstrate that we can check using this procedure any credit card number with their check digit and expiration and the CVC. We can execute this and see this was a successful result. We can test three other ones that don't have successful, like the check digit's wrong, this expiration is outdated, and our CVC is wrong on this existing card, and we'll see that those outputs are 0. So here's an output of 0 for that one. Here's the one for the outdated expiration, that's 0. And here's a bad check digit, which gave us 0. So those are kind of your two database interactions. Um, then there's some other highlights that we've got in this system. As a background on how some of these are generated, we do have users and their passwords. When they are added to an account, they have a master account, which can have multiple sub-accounts. Um, for each one of these sub-accounts, they basically have a full account number, which consists of what type of account it is, a random digit to prevent guessing that account, and then the master account number all concatenated together. So the full account number is a 13-digit number, kind of like what you would see on a check or if you were logging into a system. Um, and then for credit cards, you've got three major parts. You've got that full account number. You have a check digit, which we'll see what that does later. And then you have the actual card type like Visa, American Express, and so on. So I've got some sample queries. We'll just run through top to bottom. So the first one, we're going to test adding a new user. Basically what this is testing is a valid password. There are several constraints. In this one, we are just going to show that this is a valid password. We won't have any errors. The other thing is a trigger. Basically, when a user logs in, they need a display name. So we're not going to define one because we have a trigger that will take the first name and assign that as the display name. So let's run this query here. So you can see we did get that inserted, password was fine. Our display name was set to our first name because we didn't define that in our insert statement. The next thing that we'd like to look at is various tables must have a customer or business ID tied to them. It can only have one or the other, and it must exist. So we have a combination of checks and triggers to handle that. So here's an example of a check where neither one is defined and gives us the check constraint error. Here's a check constraint where both are defined, so that also gives us the same error. However, these two say, we have a valid check, but we need to make sure this ID actually exists. So this customer ID, we should get an error because this does not exist. So customer ID doesn't exist, and similar for business ID. And then if we did have a valid one, like the business ID does exist, or the customer ID, then it should work fine. The next thing we'd like to kind of look at is this check digit for a credit card. Basically, a credit card number or any number needs to have some sort of way to verify that it's proper. We use the LUN algorithm commonly for this. Basically, what it does is it takes some number and does certain calculations like it starts from right to left, and then every other number to start with is doubled. So 5 becomes 10, 7 to 14, and so on. After that, any two-digit numbers are added together. So 1 plus 0 is 1, 14 plus, or 1 plus 4 in 14 becomes 5, so on. So we'll add those all together. Our result set will add together completely. In this case, for this one, it gives us 63. And then Lund's algorithm is also called mod 10 algorithm, basically because this final number, we mod it by 10, and that gives us our check digit. So for this 13-digit character, we get 3. In any situation, no matter what the number is, we can use this algorithm, and the process is the same. So let's just test this and make sure we do get 3, and we do in fact get 3. Based on that, and how the concatenation happens, we can generate our whole credit card number. So the first thing we're going to test is we're going to insert into an account. We have a master account ID, and we're going to generate a random account number for the type that we want. What this does is it allows us to have 90 different accounts, and each one has a random number assigned, so you can't guess which one it is. And we have a cursor that kind of looks through, and if that random number is already there, then we just create a new random number and we assign it instead. So we have, I guess, kind of a nested while loop using cursors to check for existence. So that we'll see that demonstrated when we run this. Based on that full account number that's generated, we can then generate a credit card, which basically is a concatenation of the card type. So Visa, American Express. In this case, we're just going to do Visa. I believe this is Visa debit, so 41 is the prefix. Then we'll take our 13-digit full account number, and then we'll calculate a check digit and generate the credit card number. So let me run this here. So the first thing that we got was adding the account. So you can see we got a random number here. 73 was one that it picked. Since this did not exist already, it worked just fine. and you can see it concatenated. So we got 73. Our account type is 01. The random number to prevent guessing is 4. This one's always going to be random. And then our master account ID right here. So there's our 13-digit number. And then once we have that for a specific account, and that 13-digit number is what you'd see on the bottom of check. But once we have that, we can create a credit card, which basically says, here's the card type. We'll take that 13 digits and put it here. And then our check digit in this case for those 13 digits was 8. So our full credit card number became this 16-digit number. Should be perfectly valid. And we can verify that this works as well, which we will do later. The next thing that we want to look at is just making sure security questions users and businesses only have 5 maximum per user. So if I just run 6 here, we should have an error that says max of 5s allowed. So there's max 5. We already kind of tested the add a new account, but to give an idea of that unique account number, we'll just run this manually. You can see each time it's going to generate a random number, and this is the after it's checked for, in this case, this master account. It's checking to see, looping through a cursor and making sure that that random number is not in there. If it is, it just does a while loop and repeats the process until it finds something available. So we can run this a few more times and see that it's random each time. Okay, and as mentioned, because we have that check digit and a few other things, we can validate those credit cards. This is something farms might use. We already discussed how that would work, but now with the check digit, if that is not proper, like we saw this one earlier was not proper compared to that 13 digits, so this one failed the test, whereas this one worked. The last thing that we have is just verifying our passwords. There's a few constraints that we have. We want to make sure it's long enough, 9 digits. So in this case it's not, so we'll get an error. Just 0, it's not long enough. In this case it needs a lowercase letter, at least 1. So this one should also give us an error, so 0. In this case we need at least 1 uppercase, so this one will also error. There's our 0. For this one we need symbols since we don't have any. Basically symbols would be anything except letters and numbers. So this one will error. If I were to add a space though, this would be perfectly valid and it should give us success. So there's 1. And then the last one is it cannot contain the username. So we do check that as well. And that one gave us an error. So those are kind of the key highlights, especially the credit card process. Seems like it's the most complicated with that LUN algorithm and the check digit. So that's something that's been a challenge to work with. Another challenge to work with was actually kind of the constraints with customer and business IDs, just keeping track of how all those needed to go. Other than that, just wanted to mention a couple things on the data specifications. I did not add the activity tracking because that would have involved adding a massive amount of constraints for each table, so I just left those out but kind of made notes in the code. And that should be it. So thank you.